Hello class, so we're on to 9.5 notes over trig ratios and their inverses. Geometry allows you to find the side lengths and angles of triangles when there's not enough information to use the Pythagorean theorem. So this is where trig comes into play. So in trig, we use only one of the acute angles of a right triangle as our reference point. So technically in this case, sometimes you're just given one angle or you're just given one side, and you are able to find the other missing parts based on the one set of information. And so, if we're talking about in reference to B, it says in reference to angle B, name the following. So what is the opposite leg? So the opposite leg is what's literally across or opposite of the angle. So in this case, if I were to draw an arrow to the opposite side, then CA is considered your opposite. And I will put O or op for opposite. Okay, so AC is your opposite. Now the adjacent leg is always the one that's right next to the angle. Okay, so the adjacent leg in this case is BC. It's always right next to. So A or ADJ for adjacent. And we already noted that our hypotenuse is always across from 90 degrees, regardless of the angle you're talking about. It's always across from 90 degrees, and that is your H. And so that is AB. And so one way you're going to reference this, and you might be able to see, might have seen this for a while, it's called SOHCAHTOA. So I have S-O-H, and there's a reason I'm writing them small, C-A-H, and then T-O-A. So it's an acronym, kind of like how you use PEMDAS. Please excuse my dear Aunt Sally. SOHCAHTOA is for a trig. So the S stands for sine, C is cosine, and T is tangent. The O and the H and the A represent O, H, and A. So they talk about what order they go in. So your acronym, you can make up an acronym, or I used to say, and what my teachers have taught me is some old hippie caught another hippie tripping on acid. So it's funny and hopefully not relatable to any of you guys, but it did help me remember the acronym. And so the most common ratios are sine, cosine, and tangent. So the abbreviation for sine is just S-I-N. So it's pronounced sine with an E and not sin, as the abbreviation says. And your definition is said here. So I have sine is where you have O over H. And O means opposite, and H means hypotenuse. And so that's why I have O first, because that means it's going to go on top. Okay? Cosine, the abbreviation for that is C-O-S, cos. So for that one, I have C, and what goes on top? Well, in this acronym, I have A on top, so it would be adjacent over your hypotenuse. Okay? So I'll write it on the side. O means opposite. And then I have A, or capital A, means adjacent, which means next to. And then H means hypotenuse. Okay? That says hypotenuse. Pardon the handwriting. Now last one, talking about tangent. So, variation of that is tan. And then I have T, and your O is going to go on top of your adjacent, or A. Okay? So, that is your abbreviation. So, in this case, to express sine M, cosine M, and tan M as ratios. So, let's look at sine N. So, I'm looking at reference to N, okay? And so, I need to label what's opposite, what's adjacent, what's hypotenuse. Well, what's across from that is O, and then this would be A for adjacent, and our hypotenuse is always across 90 degrees, so that is H. So, sine M, when we said sine, is opposite over hypotenuse. Okay, so what is O? What's opposite? Well, that would be 7, and then hypotenuse is 25. So sine of M is 7 over 25. See how that works? So cosine M is adjacent. So adjacent over the hypotenuse. So adjacent would be 24 and then your hypotenuse is 25. So cosine n is 24 over 25. Then I'm left with tangent n. So tangent n is t, and then your opposite is over your adjacent. So the opposite, which is 7, over your adjacent, which is 24. So tangent of n is 7 over 24. Okay, so remember, sine, cosine, tangent of an angle is just a number. So you can use your calculator or a table to find the following. And so with your calculator, this is where we get to use the trig functions in this. So for our first one, we are looking for tangent of 50. So I have tangent of 50 degrees, but before we do that, always go to mode. So hit the mode button and go down. You see where it says radian? We're actually going to put that to degree mode. So make sure you hit that enter button and then exit out. Okay? So now it should be able to get the right answer. So I have tangent of 50 degrees. So tangent of 50 degrees is 1.19. Let's say 1.19. Okay, so I'm going to do the same for cosine. So let's do cosine of 50. So cosine of 50 is 0.64. So I'm going to do 0.64. And then I'll do sine of 50. And I get 0.77 if I'm rounding. So 0.77 if I'm rounding to the nearest hundredth place, or the second decimal place. Okay, so that is finding missing sides in reference to an angle, and then using a calculator to find your decimal points of certain trig functions. So going to page, after page 21, going to page 22. So this is where I have finding sides. So I'm going to find the sides of my missing angles. So, and I have my reference angle for number 3. So I have 53 degrees. And I'm going to label my opposite, my hypotenuse, and adjacent. Well, x is your opposite. And then this is h, across 90 degrees, and that makes 24a. So, let's say I wanted to use or find x. Can I really use the hypotenuse? I actually cannot. I can't use my hypotenuse because I don't know what it is. I need to use x and 24, or O and A. And so if I'm looking at SOHCAHTOA, which one has only an O and an A? Well, that'd be tangent. Tangent has an O and an A with it. So I'm going to use TOA, or tangent in this case. So I have tangent of 53 degrees equal to, and what goes on top? That would be O, which in this case is x, and on the bottom I have A, which is 24. Now I need to solve for x. Now, anytime dividing, you can always cross multiply. You can put tangent 53 over 1 and cross multiply, or you can multiply 24 on both sides. So now I have 24 times tangent of 53 equal to x. And if I were to type this into a calculator, I have 24 times tangent of 53 I get 31.8. So x equals 31.8. Okay? So now, let's do number 4. So number 4, I have my hypotenuse. And then what's next to my reference angle of 31 is A, and across from it is O. So now, can I really use my hypotenuse again? I cannot. And so which one that doesn't have a hypotenuse is tangent, so TOA. So, same example. So I have tangent of my reference angle, which is 31, equal to 7 over x, because 7 has the opposite first over your adjacent. Now I have x at the bottom, so I can cross multiply. I'm going to try this cross multiplying. So I'm going to cross multiply, so I have x tangent of 31 equal to 7. And then you can cross multiply. I'll put that to the side. So cross multiply. And so now I have that, but I still need x by itself. So I'm going to divide by tan 31. And so now x equals 7 over tangent of 31. Okay. So I have 7 divided by, and it always helps to use parentheses if you want to, tangent of 31, close both parts of your parentheses, and I'm left with 11.65. Okay, so you can always cross multiply in this case. Or your shortcut is always switch your x and your tan of 31. Alrighty. So, those are a couple examples. See if you can try a few more on your own. So note you'll have some where you'll have to label your sides first. So label your sides. So label your sides first. And then your second step is find which trig function. Okay, and then your last one is solve equation. Okay, and so those are your 3 steps. So make sure the probably hard part is finding which trig function. Note if there is no number or x there, you are not going to use it. So in this case, like number 5, you have your reference angle. X is O, you have A and H. I'm not going to use tangent this time because I don't have an A. I can't use cosine because I don't have an A. So the only one that has an X, 63, or O and H. So for number 5, I would use or sine in this case. Okay, so keep practicing and labeling your sides. We're going to go on to finding angles. So when I'm finding angles, I have an example. I have sine of x to the 3 is take the inverse. This is where you're using that second part there of 2 over 3. So this is kind of the opposite way. So in your calculator, you'll press second, then trig function. Okay, so a couple examples of doing that one. You're still labeling, but this time you're trying to find the angle on the inside. So I have x is my reference angle. I have O, 23 is A, and my hypotenuse is across from 90 degrees, which is H. And I can't use my hypotenuse because there's nothing there. So I'm left with, I'm looking at SOHCAHTOA. Get used to writing this all the time. I will have my opposite and adjacent, and so I'm using TOA. So I'm tan of x degrees, pardon the bell, tan of x degrees equals 51 over 23. And so I need to take the inverse of that like I did in my example. So when I do that, I'm really taking tan of the inverse of 51 over 23. And in my calculator, I have second tan of 51 divided by second tan 51 divided by 23. And so my angle measure is 65 degrees. Or if we're going to round all the way up to the whole number, it's 66 degrees. Okay, and so that's just one example, and we'll head on more examples on finding angles. So make sure this time you label. So label your functions first. and then 2 inverse trig, or with that -1 on it, okay? So that concludes our 9.5 notes. Thank you.